Hello again. This is part 5 of the tutorials on building a simple VST plugin host application in C++. This episode relies heavily on the material covered so far, so if you haven't seen the previous videos, you'll probably find it too much of a challenge to join at this point. But all these tutorial videos are available on my YouTube channel, so you are free to watch them from the beginning anytime. So let's begin. We got as far as getting a plugin to process MIDI events and generate audio data, and we sent the data to the computer's audio interface to eventually produce sound through the speakers. Timers and buffers played an important role in this process. What we haven't quite achieved is to play the sound or music in real time. So far, there have been two steps. First, all the audio data was generated and saved in memory, and only then, in step 2, was the sound data output to the audio driver and played. In this next version of the program, we will merge these two steps into one. Right from the beginning, this requires a restructuring of the code. Well, some parts of it. If you remember, we had this audio device class with a single method called playAudioStream. In this method, the audio device, or audio client as Microsoft calls it, periodically asks the host program to supply chunks of audio data to render and play. That request was filled in the loadData method. In the last version of the program, all the sound data had already been generated by the time loadData was first called. That's what I called step 1 earlier. If we wanted to play the music in real time, that could no longer be the case. The audio data has to be generated on the fly every time loadData is called by the audio client. Okay, I'm sorry if this has been a rather long-winded preamble to what I really want to say, which is that the functionality we currently have in the playMidiTune method, where the plugin processes the MIDI input and generates audio data, well, all that has to be moved into the loadData function. I created this fancy diagram to illustrate how the various components work together to produce audio output. The entire process is driven by the playAudioStream method in the audio device class. It periodically calls the loadData function in the AudioSourceX object, and in loadData, the plugin is processing the next lot of MIDI events and generates audio data, which then finds its way back to the audio device and eventually output to the speakers to produce audible sound. So now, if we looked at the program code, beginning with the playAudioStream method in audio device, it is still the same as before, except for a small change I will talk about later. Here is the while loop and the loadData function call within the loop. And it's loadData where everything is happening now. The do-while loop, where MIDI events are processed and where the plugin generates audio data, is here, and it should look familiar, at least for the most part. I just collapsed this for a minute, because there is something I need to talk about that we did not have to consider earlier. You see, loadData is executed many times, at the beginning of the song, at the end of the song, and several times in between. And we need to distinguish between the first call, the last call, and all the others. These three code segments have been created to perform those tasks. Let's look at each of them in turn. On the first call into loadData, some initialization tasks have to be performed. It is here that we reserve memory for the output the plugin generates. That memory space will be reused in every call into loadData. And to kick off the processing, The first MIDI note event is red. To prevent this segment of code from executing on subsequent calls into load data, I use this static variable, playing. Jumping to the end, to the last call into load data. Apart from doing some common end-of-processing cleanups, the important bits are to fill the rest of the buffer with silence and to set the flags variable to this value, which will cause the execution back in play audio stream to exit the while loop. The bulk of the code in the load data function is pretty much the same as what we had in the old play MIDI tune method. It is a little bit different though, because I did some fine-tuning. One problem I was having was that sometimes the very end of the song, maybe some reverb, got cut off. So I needed some extra processing time, the length of which is arbitrary. I don't have a solution for calculating exactly how long it should be. Maybe there isn't one, because I noticed that even the Windows Media Player sometimes fails to play a MIDI tune to the very end. The other notable change is the exit condition of the while loop. We still have to check whether we are at the end of the MIDI tune, but apart from that, we also have to keep an eye on the buffer we get as an argument of the load data function. If the buffer gets full, we need to exit the loop. Take a look at these two variables here. Number of frames available and number of frames provided. Number of frames available tells us how much space is available in the buffer. The buffer gets filled with block size number of frames at each iteration. Number of frames available might not be an exact multiple of block size. That is why we need the other variable, number of frames provided. And this is the little difference I alluded to earlier in Play Audio Stream. In the earlier version, this num_frames provided variable wasn't required, but now it is. Now let's go back to the main function and see how everything works from the beginning. The main function hasn't actually changed at all. There is still a call to play MIDI tune as before. However, the play MIDI tune function is altogether different now. As we saw earlier, the processing logic has been moved out of it and into the load data function. In play MIDI tune, an audio device and an audio source object is created, and then the play audio stream function of the audio device is executed. The audio source object is passed in as an argument to play audio stream. So that's how it all fits together. I hope my explanation wasn't too difficult to follow. You can always ask me in the comments if something needs clarification.